Chapter 2, Statistics. Now in Form 2, we introduced statistics, where we did data collection, recording and presentation. In data analysis, we looked at the measures of central tendency for both grouped and ungrouped data. In this chapter, we shall look at new data analysis, measures of dispersion. But first, let us revisit measures of central tendency. And we start with ungrouped data. Ungrouped data works for data that is small in size. For instance, if you walked into a class and asked the ages of 10 students, you could obtain data like this one. This is discrete data. Mean, symbolized by X bar, is the numerical average. X represents individual observations. N is the number of observations. In this case, N is 10. Mean is equal to the summation of X over N. That is 13 plus 17 plus 19 plus 18 plus 14 plus 15 plus 13 plus 17 plus 13 plus 16 over 10. That gives us 155 over 10, and that is equal to 15.5. So the mean age is 15.5 years. Mod is the number that appears most often. In this case, it's 13 because it appears 3 times, and so the modal age is 13 years. Median is the central observation when data is arranged in ascending or descending order. If you arrange this data, you shall have 13, 13, 13, 14, 15, 16, 17, 17, 18, and 19. In this case, there are 2 middle numbers, 15 and 16. The median is the average of the two. 15 plus 16 over 2 will give us 15.5 years, and so the median age is 15.5 years. Next, frequency distribution. Now, sometimes, if the amount of data is large, it becomes repetitive, meaning that some observations will appear several times. If, for example, you walked into the same class and asked the ages of 120 students, you would expect many of them to have the same age. You might find 20 students being 10 years old. So you don't want to write 10 years 20 times. We instead use a frequency distribution like this one. From this frequency distribution, you see there are 12 students who are aged 8 years, 23 students are aged 9, 26 students are aged 10 years, and so on and so on. We can calculate the measures of central tendency for a frequency distribution. But first, we arrange the data into columns. Ages are the observations, so we use X. The number of times an observation occurs is called frequency, and it's represented by F. The summation of frequency gives the total number of students. Mean. The mean for a frequency distribution is given by 2 methods. 1, the direct method, and 2, using an assumed mean. Let's start with the direct method. In direct method, mean is equal to summation of fx over the summation of f. From this formula, it means we need another column of fx. That is, we multiply each observation by its corresponding frequency. So these are the observations and their corresponding frequencies. To get fx, we have 8 times 12 will give us 96. 9 times 23 is 207. 10 times 26 is 260. If you do the same for the rest, you'll have 275, 240, 156, and 28. The summation of fx, we shall have 96 plus 207 all the way down, and we get 1262. The the summation of frequency is the total number of students, 120. Therefore, mean is equal to 1262 over 120, which gives us 10.5 years. Now we use the assumed mean method. Now, when the number of members in a list is large, the direct method of finding the mean is quite odorous. From the data, we can guess the expected value of the mean. This expected value is called the assumed or working mean, represented by A. The assumed mean is approximately in the middle of the data. In a frequency distribution table, the model value provides the best assumed value. But then, the assumed mean does not have to be one of the values given. After we choose the assumed mean, we find by how much each observation differs from the assumed mean. This difference is called the deviation D. D is equal to x minus A. And then, mean is given by A, the assumed mean, plus summation of FD over summation of frequency. From the formula, it means we need a column for D deviations and then another one for FD. Let's have an assumed mean of 10. We now calculate D. 8 minus 10 is minus 2. 9 minus 10 is minus 1. 10 minus 10 is 0. 11 minus 10 is 1. 12 minus 10 is 2. 13 minus 10 is 3. And 14 minus 10 is 4. Now FD, we multiply the frequency times the corresponding deviation. 12 times minus 2 is minus 24. 23 times minus 1 is 23. 26 times 0 is 0. We proceed the same and we shall get 25, 40, 36 and 8. Summation of FD is 62. Summation of frequency is still 120. Therefore, mean is equal to 10 plus 62 over 120. That is 10 plus 0.5, giving us 10.5 years, the same figure we obtained with the direct method. And so, you see, by knowing the formula, you will know which column to create. The mode for a frequency distribution is the observation with the largest frequency. In this case, the model age is 10 years because it has a frequency of 26. Next is median. Now, in order to find the median of an ungrouped frequency distribution, we introduce another column called the cumulative frequency, which is basically the running total frequency. This is how we obtain the cumulative frequencies. We have our observations and their corresponding frequencies. The first cumulative frequency is 12, same as the first frequency. To get the second cumulative frequency, we will add the first cumulative frequency to the second frequency. So we have 12 plus 23, and that gives us 35. To get the third cumulative frequency, we add 35 plus the next frequency, that is 26. That gives us 61. Then we proceed. 61 plus 25 gives us 86. 86 plus 20 is 106. 106 plus 12 is 118. 118 plus 2 is 120. We know the median is the middle value. There are 120 observations. Being that it is an even number, it means there are two values in the middle. That is observation 60 and 61. Reading the cumulative frequency column, the 35th student is aged 9 years. From the 36th to 61st student, they are all aged 10 years. It therefore means that the 60th and 61st student are aged 10 years. So we get the average. 10 plus 10 over 2 is 10 years. Next, we look at grouped data. Now again, when the amount of data is too large, we often categorize it into classes. For example, if these are the scores in an exam, if you form a frequency distribution table, it will still be long. Instead, you can group the scores into categories, say with a range of 10 marks. To do this, you look at the highest and the smallest scores. For this case, let's have a range of 10. So we would have 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Now, when working with grouped data, there is a new column that you must form. That is the midpoint. In the column for classes, we have class limits. In the class of 50 to 59, 50 is called the lower limit and 59 is the upper limit. For the class of 70 to 79, 70 is the lower limit and 79 is the upper limit. To find the midpoint for each class, we get the average of the upper and lower limit. So for the first class, we would have 50 plus 59 over 2, giving us 54.5. Second class, 60 plus 69 over 2 gives us 64.5. Third class, 70 plus 79 over 2 gives us 74.5. Fourth class is 84.5 and the last one is 94.5. The midpoint now represents our observations, x. Any other column will be formed depending on the formula. We calculate the mean. To calculate the mean for grouped data, you can use the direct or the assumed mean method. For the direct method, mean is given by summation of fx over the summation of frequency. Notice that for grouped data, x is the midpoint. From the formula, it means we will need another column for fx. We multiply each midpoint by the corresponding frequency. 54.5 times 1 is 54.5. 64.5 times 7 is 451.5. 74.5 times 4 is 298. If you proceed like that, you will get the fourth one, 253.5, and the last one, 94.5. The summation of frequency is 16. The summation of fx will be 1152. And therefore the mean is equal to 1152 over 16, giving us 72. For the assumed mean method, mean is given by A plus summation of FD over the summation of frequency. Looking at the formula, it means we choose an assumed mean A and then get another column for D and another one for FD. Recall that D is equal to X minus A and that X in grouped data are the midpoints. So let's take an assumed mean of 74. We calculate D for each class. First one, 54.5 minus 74 is minus 19.5. 64.5 minus 74 is minus 9.5. 74.5 minus 74 is 0.5. 84.5 minus 74 is 10.5. 94.5 minus 74 is 10.5. Now we multiply the deviations and the corresponding frequencies. 1 times minus 19.5 is minus 19.5. 7 times minus 9.5 is minus 66.5. 4 times 0.5 is 2. 3 times 10.5 is 31.5, and 1 times 20.5 is 20.5. The summation of FD will give us minus 32. And therefore mean is equal to the assumed mean 74 plus minus 32 over 16. That is equal to 74 plus minus 2, giving us 72, the same mean. The model class is the one with the highest frequency, that is 60 to 69. Next is the median. Now, when working the median of grouped data, yet another column is introduced: class boundaries. To obtain the class boundaries, we subtract 0.5 from the lower class limit and add 0.5 to the upper class limits. And so for the first class, 50 to 59, 50 minus 0.5 is 49.5. And then 59 plus 0.5 will be 59.5. Second class, 60 minus 0.5 is 59.5. 69 plus 0.5 will be 69.5. The other classes, we shall have 69.5 to 79.5, 79.5 to 89.5, and 89.5 to 99.5. And so you realize the upper class boundary for a given class is the lower class boundary for the next class. As usual for median, we need the cumulative frequency. Another column we need is the class size. Here, we subtract the upper boundary minus the lower boundary. If we do that, it appears all classes have class size 10. The median of a grouped data is found in the same way as that of ungrouped data. The calculations to find the median of grouped frequency distribution are slightly longer because the data have been grouped into intervals. When calculating the median of grouped data, the members of a class interval are considered to be evenly distributed throughout that interval. It is not correct to take the midpoint of the interval of the class in which the median is found as the median, because this will be an oversimplification of the true value. Now, from the cumulative frequency, we have 16 observations. And so the median are in the 8th and the 9th positions. We get the average, 8 plus 9 over 2 is 8.5. And so strictly speaking, the median is in position 8.5. Going to our table, the cumulative frequency up to the class of 60 to 69 is 8, and 70 to 79 is 12. It means therefore that 8.5 lies in the class of 70 to 79. This is the median class. We take the upper class boundary of the class immediately behind the median class. In this case, we will take 69.5. In other words, we are saying up to the 8th observation, we have 69.5. But then the midpoint is at position 8.5. We still need 0.5 observations. This 0.5 will come from the next class, 70 to 79. The class size is 10 and the frequency is 4. So we have 4 over 10 times 0.5, giving us 0.2. This we add to 69.5 and we shall get 69.7. So that now we move to measures of dispersion. Now, dispersion is a measure of how the distribution of data is spread out. It's another way of analyzing data. Measures of dispersion include range, deviations, variance, and standard deviation. Let's see the measures of dispersion for an ungrouped data. These were the ages of students in a class. Range is the difference between the largest and smallest value in a set of data. In this case, range will be equal to 19 minus 13, giving us 6. Deviation is the difference between each piece of data and some fixed value, usually the mean. For example, in our case, the mean for the data was 15.5. Deviation will be calculated as x minus x bar. We can find the deviation of each data from this mean. So let's rewrite our values in column form. X are the observations, and then we have x minus x bar. Recall that x bar is the mean. So 13 minus 15.5 is minus 2.5. 17 minus 15.5 is 1.5. 19 minus 15.5 is 3.5, all the way down. Now, interestingly, if you add the deviations, you will notice that the sum is 0. That is, summation of x minus x bar is 0. But then, since we are only interested in knowing the difference between the individual data and the mean, we do not concern ourselves with which one is larger or smaller than the other between the data and the mean. So we often ignore the negative sign and get what we call the absolute deviations. In this case, if we ignore the signs, we introduce another column for absolute deviations. The absolute value for the first one is 2.5. We have 1.5, 3.5, all the way down up to 0.5. The absolute value or modulus of a number is the magnitude of that number regardless of the sign. When we divide the total absolute deviations by the total number of observations, we get the mean absolute deviation. In this case, the total absolute deviations, that is 2.5 plus 1.5 plus 3.5 all the way down, will give us 19. The total number of observations is 10, so 19 over 10 will give us 1.9. This is the mean absolute deviation. Notice that the deviation in this case is calculated from the true mean and not an assumed mean. What if it's a frequency distribution, like the one we had before? First, we find the mean. Mean is given by summation of fx over the summation of frequency. That was 1262 over 120, which gave us 10.5. Now we calculate the absolute deviations, x minus x bar. So we have 8 minus 10.5 is minus 2.5. The absolute value is 2.5. We ignore the sign. 9 minus 10.5 is minus 1.5. We ignore the sign and get 1.5. 10 minus 10.5 is minus 0.5. We ignore the sign again. And if we proceed like that, we shall get 0.5, 1.5, 2.5, 3.5. For a frequency distribution, the mean absolute deviation is given by summation of f times x minus x bar over the summation of frequency. Looking at this formula, it means we need another column for f times x minus x bar. So we multiply the frequency times the absolute deviations. So for the first one, 12 times 2.5 is 30. 23 times 1.5 is 34.5. 26 times 0.5 is 13. If we proceed like that, we get 12.5, 30, 30, and 7. And then we get the summation of that, and it gives us 157. And therefore, the mean absolute deviation will be 157 over 120, which gives us 1.31, correct to 2 decimal places. Next, variance and standard deviation. Now, variance is the average of the square of the deviations from the mean. Variance is equal to summation of x minus x bar squared over n for discrete data. Notice from the formula that because we are squaring the deviations, the negative sign will be eliminated. So, for example, in our case for the age of 10 students, we had x, the observations, which is the ages of students. We had also calculated the mean and found it to be 15.5. From that, we also found the deviations of each age from the mean age. Now we square that deviation, that is x minus x bar squared. Minus 2.5 squared is 6.5. 1.5 squared is 2.25. 3.5 squared is 12.25, all the way down. The summation of the square of those deviations gives us 44.5. And so variance is equal to 44.5 over 10, which gives us 4.45. The standard deviation is the square root of variance. That is, standard deviation is equal to the summation of x minus x bar squared over n, the square root of whole. So in this case, our standard deviation will be the square root of 4.45. For frequency distribution including grouped data, variance is equal to summation of x minus x bar squared over the summation of frequency. And that means the standard deviation will be the square root of that. That is, standard deviation is equal to summation of f times x minus x bar over the summation of frequency, square root of whole. We can simplify the variance formula to variance is equal to summation of fx squared over summation of f minus mean squared, which makes the standard deviation formula to be standard deviation is equal to the square root of summation of fx squared over the summation of f minus mean squared. In each case, remember that mean is equal to summation of fx over the summation of frequency. This simplified formula is easier to work with, and the table you form will be simpler. By knowing the formula, you will know what to have on the table, so always write the formula first. If you used the assumed mean, you can use it to calculate the standard deviation, but the formula will be different. Standard deviation will be equal to summation of f times x minus a squared over the summation of frequency minus the summation of f times x minus a over summation of frequency, everything squared, and then the square root of whole. But then, given that x minus a is equal to d, then the standard deviation formula becomes the summation of fd squared over the summation of frequency minus the summation of fd over summation of f squared, the square root of whole. And so we will take 3 examples, each for one type of data, and we shall calculate the mean, mode, median, and the standard deviation so we can be very clear. So find the mean, mode, median, and the standard deviation for the following sets of data. We start with A. Mean x bar will be equal to the summation of x over n. If we do that, we shall get 91 over 7, giving us 13. Mode is 7 because it occurs twice, more than any other observation. Median, we arrange the data in ascending order. We have 7, 7, 9, 13, 15, 17, 23. The median mass is 13 kilograms. Next, standard deviation. We write the formula first so that we know what we need. For discrete data, standard deviation is equal to the square root of summation of x minus x bar squared over n. From this formula, it means we need x minus x bar. So we write our data in columns. The deviations, we calculate x minus x bar for each observation. The mean was 13. So 17 minus 13 is 4. 15 minus 13 is 2. 23 minus 13 is 10. 9 minus 13 is minus 6. 7 minus 13 is minus 4. 13 minus 13 is 0. And 7 minus 13 is minus 6. Then we square the deviations. 4 squared is 16. 2 squared is 4. 10 squared is 100. Minus 6 squared is 36. Minus 4 squared is 16. 0 squared is 0. And minus 6 squared is 36. The summation of the square deviations is 208. Therefore, the standard deviation will be the square root of 208 over 7, giving us the square root of 29.71, which gives us 5.45. Of course, to find the variance, you simply remove the square root sign. Next we go to B. It's a frequency distribution. First we rewrite it in columns. Mass is x and the number of bricks is the frequency. We write the formula first. Mean x bar is equal to summation of fx over the summation of f. Standard deviation is equal to the square root of summation of fx squared over summation of f minus mean squared. And so to get the mean, we will need a column for fx. For median, we will need cumulative frequency. To get the standard deviation, we will need a column for x squared and another one for f times x squared. Fx, we multiply x times the corresponding frequency. 2 times 3 is 6. 3 times 7 is 21. 4 times 2 is 8. Then we proceed and we shall have 30, 30, and 14. Summation of fx is 109. Summation of frequency is 25. Next, x squared. We square each observation. 2 squared is 4. 3 squared is 9. 4 squared is 16. Then we have 25, 36, and 49. Then we multiply f times x squared. So we have 3 times 4 gives us 12. 7 times 9 is 63. 2 times 16 is 32. 6 times 25 is 150. And we have 180 and 98. The summation of f times x squared is 535. Cumulative frequency. The first one is 3, 3 plus 7 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 5 is 23, and 23 plus 2 is 25. I believe that is sufficient. So mean x bar is given by summation of fx over summation of f, that is 109 over 25, giving us 4.36 kilograms. Mod is the one with the highest frequency and it's 3 kilograms. Median, there are 25 observations, so the median is at position 13. The 12th brick weighs 4 kilograms according to the cumulative frequency. It means that the 13th brick weighs 5 kilograms, and that is the median. Standard deviation is given by summation of fx squared over summation of f minus mean squared, square root of whole. We already have the mean, that is 4.36 kilograms. So the standard deviation will be equal to 535 over 25 minus 4.36 squared, square root of everything, giving us the square root of 2.4, which is 1.55, correct to 2 decimal places. Notice that we have calculated the mean and the standard deviation using the direct method. If the question required us to use the assumed mean method, we could still have done that, only that the table would look different because of the formula. Lastly, we go to C, the grouped data. What do we need? We arrange it in columns. The scores are the classes and the number of students is the frequency. Because of the median, we need the class boundaries. And for all purposes, we need the midpoints. Then the frequencies. Again, for the median, we need the cumulative frequencies. That's the very basic we should have. Now we write the formula so that we see what we need to add. Mean is equal to summation of fx over the summation of f, which means we need a column for fx. Standard deviation is equal to the summation of fx squared over summation of f minus mean squared, the square root of whole, which means we need another column for x squared and another one for f times x squared. Class boundaries. We subtract 0.5 from the lower limit and add 0.5 to the upper limit. For the first class, we shall have the boundaries 14.5 to 24.5. The next one, 24.5 to 34.5, all the way up to the last one, 74.5 to 84.5. Midpoints. We find the average of the class limits. First one, 15 plus 24 divided by 2 is 19.5. 25 plus 34 over 2 is 29.5. All the way to the last one, 75 plus 84 over 2 is 79.5. Then the frequencies, if we add all the frequencies, then we shall have 35, which is the summation of f. Cumulative frequencies, we have the first one is 6. 6 plus 11 is 17. 17 plus 7 is 24. 24 plus 4 is 28. 28 plus 4 is 32. 32 plus 2 is 34. And 34 plus 1 is 35. That matches with the total frequency, which means we are right. Then f times x, we multiply the frequency times the corresponding midpoint. 19.5 times 6 gives us 117. 29.5 times 11 is 324.5. 39.5 times 7 is 276.5, all the way to the last one, 79.5. The summation of fx will be equal to 1372.5. Next column is x squared. We square the midpoints. 19.5 squared is 380.25. 29.5 squared is 870.25. 39.5 squared is 1560.25, all the way to the last one, 6320.25. Then fx squared. We multiply this x squared times the corresponding frequencies. 380.25 times 6 will give us 2281.5. 870.25 times 11 will give us 9572.75. 1560.25 times 7 will give us 10,921.75, all the way to the last one, 6,320.25. The summation of f times x squared will give us 62,718.75. So we are good. Mean is equal to summation of fx over summation of f, which is equal to 1372.5 over 35, and that gives us 39.21. Model class, the one with the highest frequency, is 25 to 34. Median. We have 35 observations from the cumulative frequency. The median lies in position 18. Now, up to the class of 25 to 34, there are 17 observations. So we need one more observation to get to the median class. That observation is in the next class, 35 to 44. This is the median class. So we take the upper class boundary for the class immediately behind. That is 34.5. We get the class size for the median class. 44.5 minus 34.5 is 10. The median class has a frequency of 7. It means these 10 marks are distributed among 7 students. So we have 34.5 plus 1 times 10 over 7, giving us 35.93. Lastly, standard deviation. That will be given by the summation of fx squared over summation of f minus mean squared, the square root of everything. We already have the mean, that is 39.21. So the standard deviation will be equal to 62,718.75 over 35 minus 39.21 squared, and it's equal to 15.95. Try working the mean and the standard deviation using the assumed mean method. Lastly, we look at the cumulative frequency curve. Now, a cumulative frequency curve, also called an ogive, is the graph obtained when the cumulative frequencies are plotted against the upper class boundaries for a given set of group data. For example, in our case, if we take the upper class boundaries and their corresponding cumulative frequencies, we will obtain this kind of data. We plot the cumulative frequencies on the y-axis and the upper class boundaries on the x-axis. When we join the points, we obtain this S-shaped curve. All cumulative frequency curves take this shape. Using this curve, we can find what we call quartiles and percentiles. Quartiles. Now, when data is arranged in ascending numerical order and then divided into 4 equal parts or quarters, The value at the end of each quarter is called a quartile. The first quarter, Q1, is called the lower quartile. The second quarter, Q2, is called the middle quartile. And the third quarter, Q3, is the upper quartile. Notice that Q2 is also the median. So in our case, we have a total of 35 observations. So Q1 is equal to 1 over 4 times 35, which is 8.75. Q2 is 1 over 2 times 35, which is 17.5. And Q3 is 3 over 4 times 35, which is 26.25. So to find the quartiles, we go to the graph. Q1 corresponds to a cumulative frequency of 8.75. We draw that line at 8.75 to meet our curve. We go down and read the value on the x-axis. It looks like 27. Q2, or the median, corresponds to a cumulative frequency of 17.5. Draw that line to meet the curve, go down and read the value. It's 35.5. Q3 corresponds to 26.25. We draw that line to meet the curve and go down. We read the value again. The difference between Q3 and Q1 is called the interquartile range. Next is percentiles. This comes from percentage, that is 100 parts. If data is divided into 100 equal parts, each part is called a percentile. The 10th part is the 10th percentile. The 80th part is the 80th percentile, and so on. It therefore means that Q1 is also the 25th percentile. The median of Q2 is the 50th percentile, and Q3 the 75th percentile. When we want to find a certain percentile, we calculate the cumulative frequency that corresponds to that percentile. For example, let's find the 40th percentile of our data. We have 35 parts, so 40 over 100 times 35 is 14. So the 40th percentile corresponds to cumulative frequency 14. We draw that line to meet our cumulative frequency curve and read the value down. It's 32.0. 60th percentile, 60 over 100 times 35 is 21. We draw that line and read the value on the graph. It's 39.5. Finally, interpreting the cumulative frequency curves. Now, when given a cumulative frequency curve, you can use it to give several interpretations. For example, this is a cumulative frequency curve for check-in times at an airport, and we are going to use it to answer some questions. First, looking at the curve, the last cumulative frequency is 120. It means there were a total of 120 persons checking in at the airport on the day the data was collected. Question 1. Find the number of people waiting less than 25 minutes to check in. Now, the words less than are very important because the person waiting for exactly 25 minutes is not waiting for less than 25 minutes. What we do is come to 25 minutes and draw a line to meet the curve. Then across, the number there is 30 people. It means the 30th person waits for exactly 25 minutes, which is not less than 25. And since we don't have a fraction of a person, we say that 29 people then are waiting for less than 25 minutes. Question 2. The number of people waiting for more than 35 minutes to check in. Again, The person waiting for exactly that 5 minutes is not included. We go to 35 minutes, draw a line up and then across. And the value here is 59. So the 59th person is waiting for exactly 35 minutes. Everyone else up to the 120th person waits for more than that 5 minutes. So we have 120 minus 59, giving us 61 persons. Question 3. Find the median check-in time. We have 120 persons, so 1/2 times 120 is 60. Go across and then down. The value is 35 minutes.
The way we teach it in university and in high school as well, and colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor.